Welcome back. This is AG3 8.3.1. We're trying to find corresponding lengths in similar polygons. Our essential question is, how are similar polygons related? So I'm pulling straight from the book. So once again, I expect you to try to follow along, take notes as needed, look at the examples. So let's get started. So in the book, it gives us a core concept. And the core concept says that corresponding parts of similar polygons or similar or congruent. So in the diagram below, triangle ABC is similar to triangle DEF. And so what's happening is the order of these letters matters greatly. And A is similar to D, B is similar, congruent to E, and C is congruent to F. And so we can write triangle ABC is similar to DEF, and that triangle ABC in this little squiggly line means similar to triangle DEF. A similarity transformation preserves angle measure. So we now can say that A is congruent to D, B is congruent to E, and C is congruent to F. They have the same values regarding the angle measure. And then the corresponding angles are congruent. A similarity transformation also enlarges or reduces the side lengths by a scale factor of K. So corresponding side lengths are proportional. What that means is we can solve for them using ratios. And so in our diagram, we know that ABC is similar to DEF, but angle A has the same value as angle D. Angle B and E, angles B and E have the same value, so does C and F. And then we can say that whatever we multiplied C by in order to get our new value, which is K times C, we had to multiply A by the same K and B by the same value. And what this helps us do is we know that the corresponding angles, which I stated a minute ago, angle A is congruent to D, angle B is congruent to E, and angle C is congruent to F. But we also know that DE, and notice that DE goes right here on the front, is also similar to, and the same two letters in the same position as AB, so it goes similar to AB. So we can write the value of DE over AB, and that ratio or proportion is equal to EF. Notice EF's our last two letters, and that's going to be written over BC. FD is our last letter and our first letter, so it's going to be our last letter, which is C, and our first letter A. FD is equal to over CA. So all these proportions, when we get numbers, are all going to be the same number, and that same number is going to be our K. Well, how does this help us? This helps us figure out when we're trying to solve missing values. So let's try this. We're going to be using similarity statements, and we're going to try to solve. In the diagram, triangle RST is similar to triangle XYZ. So RST, I cut off the T, apologize, is similar to XYZ. So we know that the angle R is the same as angle X, angle S is the same as angle Y, and angle T is the same as angle Z. And then we know the scale factor, RS over XY is equal to ST over YZ. I'm sorry, let's say it the other way. XY is over RS is similar, or it's proportionate or equal to YZ over ST and ZX over TR. We want to list all pairs of congruent angles, and we want to write the ratios of corresponding side lengths. So let's do this. This is the scale factor. So XY over RS, we always write this one on top, our second part on top. XY over RS, so XY is 12 over RS, RS is 20, 12 over 20 is 3 over 5. And that should be the same as the rest of them. Let's check them out. So YZ is 18 over ST 30. If we reduce that, we always want to reduce it, which will give us 3/5. And then our last part is ZX over TR, and that should be 15 over 25, which gives us 3/5. So that's the scale factor. 3 over 5 is our scale factor. We stated all the congruent angles, and we can get that straight from our similarity statement up here. The letters in order are similar to each other, are congruent to each other. And then Because the ratios in part A are equal, we know that this is a statement of proportionality. We can use this to find a missing side. So in the diagram, triangle DEF is similar to MNP. We want to find the value of x. And so here's our two shapes. DEF is similar to MNP. And so we want to find this missing side. This is EF. We come over here. EF is the same value or similar to NP. So that's going to be 30. So we can get 30 over x. And we can just pick any of these other sides to write it equal to. Is equal to, and we just can use 18 over 15. So MN 18 over DE, similar side, which is our 15, is equal to NP over EF. But we don't know EF, so we're going to put in the value of x. And once we do this, if you had me before, we do the butterfly. We cross multiply. 18x time equals 15 times 30. So 18x equals 450. To solve for x, we're going to divide both sides by 18. 18 cancels out by 18, and we get x equals 25. So our missing value is 25. It's not super hard if we just take our time and list the corresponding sides over each other and write our similarity statement. We always start off with our proportion. I would use the letters and then substitute in the values and then solve. So the total value of x is 25. In summary, the order of the letters matters in a similarity. You need to write them in order. You need to pay attention to the order that they're in. And then in order to solve for the x, we want to write the proportion to find the missing side values. Look at the form, so answer the questions, and then look for more videos.